How does machine learning understand physical world? Machine learning is often described as a digital brain, but a more accurate way to think of it is as a master of patterns. While traditional software follows a strict set of rules written by a human, essentially a "if this happens, do that" manual, machine learning looks at vast amounts of data to discover those rules for itself. Imagine trying to teach someone how a swing moves just by showing them thousands of videos of people in a park. Eventually, that person would notice that the higher the swing goes, the faster it falls back down. Machine learning does something very similar with numbers. It uses mathematical structures called neural networks to map out the relationship between an input, like the starting height of a swing, and an output, like its speed at the bottom. This ability to learn from observation is what allows it to understand complex physical phenomena that might be too messy or detailed for a human to write down in a single equation. When we talk about machine learning, understanding physics, we are usually looking at two different approaches. The first is purely data-driven. If you give a computer enough sensor data from a car driving through the wind, it can start to predict how air flows around the vehicle without ever being told about the laws of aerodynamics. It simply recognizes that certain shapes consistently lead to certain types of wind resistance. The second, and perhaps more exciting approach, is called physics-informed machine learning. In this case, we don't just give the computer raw data, we also give it a cheat sheet of the laws of nature, such as the fact that energy cannot be created or destroyed. During its learning process, whenever the computer makes a guess that violates these laws, it receives a mathematical penalty. Over time, the machine learns to make predictions that are not only based on the patterns it saw in the data but also strictly follow the rules of the physical world. This makes the models much more reliable because they won't suggest something impossible, like a ball falling upward. In the real world, this technology is already changing how we build and maintain the things around us. One of the most common applications is in predictive maintenance for manufacturing. Large factories are filled with complex machines that are expensive to fix if they break down unexpectedly. By using machine learning to monitor sensors that track heat, vibration, and sound, companies can understand the physical state of a machine in real time. The AI can detect tiny, invisible changes in a motor's vibration that signal a failure is coming weeks before a human would notice anything wrong. This allows engineers to fix the part during a scheduled break rather than dealing with a sudden, costly shutdown. It's essentially giving the machines a way to tell us they are feeling sick before they actually collapse. Beyond the factory floor, machine learning is a powerhouse in weather forecasting and environmental science. Predicting a hurricane or a heat wave involves tracking millions of variables across the atmosphere. Traditional simulations are incredibly slow because they have to solve trillions of math problems every second. Machine learning can speed this up significantly by learning the shortcuts of how air and water move. This doesn't replace traditional meteorology but acts as a turbocharger, allowing scientists to run thousands of different scenarios in the time it used to take to run just one. This leads to more accurate warnings for natural disasters, potentially saving lives by giving communities more time to prepare. In healthcare, these same principles are being used to understand the physics of the human body. When scientists develop new drugs, they need to know how a tiny molecule will physically dock into a protein in your cells. This is a massive physical puzzle with billions of possibilities. Machine learning can simulate these physical interactions at a scale humans could never manage, identifying potential cures for diseases in months rather than decades. From making cars more aerodynamic to help them use less fuel, to designing more efficient wind turbines by understanding the physics of the breeze, machine learning is moving from being a tool for digital apps to becoming a fundamental partner in how we interact with the physical universe. Thank you for your attention and see you soon in the next video. Please let me know your opinion in the comment section.